So the past couple days, we have learned how to write the name of a binary compound when given a formula, and how to write the formula of a binary compound when given the names. And we've learned this just for binary compounds, but not all compounds are binary compounds. We have binary, remember, means it's only two ions or two atoms. And we often have what are called polyatomic ions. Polyatomic ions are a group of atoms. So they're together as a group. And they, as a group, have a charge. This shows some common polyatomic ions that you are going to have to know. And it shows the name ammonium, it shows the formula NH4, and it shows the charge being 1+. And you can see the rest of those there. So these are ones that you're going to have to know and you will be using very often. We're going to take a look now at how we name a compound that contains one of these ions. First thing is to know you do not change the ending to IDE. If it is an anion, if it is a negative polyatomic ion, you do not change the ending to IDE. You always just leave the name as is. So rule number 1 says you write the name of the positive ion. Then rule number 2 says you write the name of the negative ion. And it gives an example there. K2SO4 is K is potassium, SO4 is sulfate, so it's simply potassium sulfate. So let's take a look at these examples here. We have NH4. If you remember from the list of the polyatomic ions, NH4 is ammonium. So I write the name ammonium. And then I have O, which is oxygen. But it's just oxygen forming a compound, so it turns into oxide. So my answer, the name of NH4,2O is ammonium oxide. Second example, calcium. And PO4 is my second ion, and it is phosphate. So the name is calcium phosphate. Next one, the positive ion name is sodium. The negative ion name is chlorate. So the name is sodium chlorate. Going the other way then, if we want to write the formula when given a name, we follow the same rules for writing formulas for binary compounds with one addition, one possible addition. We need parentheses around a group, the group representing the polyatomic ion, if there's more than one. So it says there when more than one of that ion is needed. Example, Ca3, parentheses, PO4, parentheses, 2. And we'll look at why we need that in the following example. So the first one we have is ammonium sulfate. Ammonium, if you remember, is NH4. NH4, and it's a 1+. Sulfate is an SO4, and it is a 2-. So now what I need to do is I need to crisscross. If I just take and cross this 2 and put it down there, it looks like I have 42 hydrogens. So we don't have 42 hydrogens, we have 2 NH4s. So I need to put parentheses around the entire NH4 and show there's 2 of them. Now I do not need parentheses around the SO4 because I don't have to cross the 1. So it's obvious that I have 1 SO4. I don't need parentheses to show that. Let's look at the next one, calcium acetate. Calcium is Ca. It is a 2+, oxidation end. Acetate is C2H3O2, and it's a 1-. So I have to cross the 2, and I need to put parentheses around the entire polyatomic ion and put the subscript of 2. I do not have to cross the 1 and put anything behind calcium. Aluminum hydroxide. Okay, aluminum is a 3+. Hydroxide is OH. It's a 1-. This is a tricky one. because a lot of people forget to cross or to put parentheses around the polyatomic ion here, because I could put the 3 here and it doesn't look like I have 23 or 33 or 43 or anything like that. But the reason why I can't do that is because this shows that I only have 3 hydrogen but only 1 oxygen. And really what I have is I have 3 of the OHs. So I do need parentheses around that. And that's one of the more common mistakes that you're going to find made. Last one here, magnesium carbonate. Magnesium is a 2 plus. Carbonate is a CO3 and it is a 2 minus. I don't have to cross them because they're both 2s. They cancel each other out. So I do not need parentheses. Again, I only need parentheses when more than 1 of the polyatomic ion is needed. If there's only 1, I do not need any parentheses. So tomorrow in class, what we're going to do is we're going to take a look at a couple of more difficult examples. And that is when we are using transition elements, which can have more than 1 oxidation limit.